Okay, so this is question 3, and we've got 3 times the modulus of x plus 1 minus the modulus of x minus 4 is less than or equal to 11. And we're trying to find the set of values of x that satisfies this inequality. So what we're going to do first is we're going to look at each one of these modulus equations in separation and see how these behave, and then find the respective functions across the whole set of values of x. So if we think of this function here, the modulus of x plus 1, if we think of the line y equals x plus 1, the line equals x plus 1 has a gradient of 1, we'll go through the y-axis at 1, so it'll be a line somewhere down here. And we've got the modulus of this function, and that the modulus was going to take this part and make it positive, so this bit here will then reflect in the x-axis to give me a line doing something like that, and then this bit here will now disappear. So we've got this first critical point here, which is at minus 1. So we can now imagine an equation for this line along here, and the equation for this line is going to be 3 times this function, but this function now is going to be multiplied by minus 1, 3 times minus x plus 1, and the multiplication by the minus 1 is equivalent of reflecting this in the x-axis. So we've now got minus 3x minus 3. Then along this area here we simply got 3 times x plus 3, so over here we've got y equals 3x plus 3, and this should have been a y here. Now again we'll take a look at this other function over here, x minus 4, and it would, if you think of the curve or the straight line y equals x minus 4, it would go through the y-axis at minus 4, say down here somewhere, with a gradient of plus 1, so it's going to be doing something like that. And the modulus will reflect this part of the line in the line y in the x-axis rather, to give me a line now doing this. Okay, so the equation of this line along here is y equals x minus 4, and reflecting in the x-axis, reflecting this part in the x-axis, is equivalent to multiplying by minus 1, so the equation of this line is y equals minus x minus 4, which is equal to minus x plus 4. And now we can get rid of this part of the line, and we've got this critical value here now of 4. So along each section here we can divide the diagram now into 3 sections, and we'll look at bringing now these equations together in each of these 3 sections. So in this section here, x less than minus 1, we've got the equation minus 3x minus 3, and then we're subtracting the equation for this line here, which is minus x plus 4. So what we've, and this is y. So y is equal to minus 3x minus minus x, minus and minus is a plus, so we've got minus 2x minus 3 minus 4, so this is minus 2x plus 7. In this region here from minus 1 to 4 we have got our expression for y, which is now 3x plus 3, and we're subtracting this equation here, which is minus x plus 4. So I've now got 3x minus x, which is minus and minus is a plus, so I've got 4x. I've got 3 minus 4, which is now minus 1. And then in the final part, for x greater than 4 in this region along here, again we've now got this equation. We've got y is equal to 3x plus 3, which is this equation, minus this equation here, minus the x minus 4, which is now 2x, 3x minus x is 2x. 3 minus minus 4 gets me plus 7. Okay, so for the second part of this question, or the continuation of the question, we now take our three equations and we apply them to this inequality where the inequality is less than or equal to 11 to get the set of values for x. So we'll look in this region here, x being less than minus 1. So over here we've got minus 2x minus 7 is less than or equal to 11. Take the 7 across, minus 2x is less than or equal to 18. Divide through by the 2 means that minus x is less than or equal to 9. Multiply both sides by minus 1 means that x is over here. We've got a minus 9 here, and when we're multiplying by minus 1 we reverse the direction of the inequality. So x is greater than or equal to minus 9. Okay, or we can write it if we want as in this form here, x is greater than or equal to minus 9. Okay, now for the second bit, this bit here between x is minus 1 to 4, again we're going to equate the equation over here. 4x minus 1 is less than or equal to 11. Take the minus 1 across, so 4x is less than or equal to 12. Divide through by the 4, so x is less than or equal to 3. And then the third piece over here, 2x plus 7 is less than or equal to 11. Take 7 off both sides. 2x is less than or equal to 4, so x is less than or equal to 2. So the important pieces here are these two bits here. These are effectively the end parts of our inequality. So x is going to be greater than or equal to minus 9. X is less than or equal to 3. And in this value here, x less than or equal to 2 is within the range of values that we've got here. So our set of values is the set of x being greater than or equal to minus 9, less than or equal to 3.